Hi. So this is one of the question in M1. This is question from M1 book. Okay, review exercise. M1 book. Review exercise. Okay, review exercise 2 most probably. Question number 46. So they said a destroyer is moving due west at a constant speed of 10 km per hour. So it has a radar. So a destroyer is moving due west at a constant speed of 10 km per hour. Okay, and it has a radar on board. Time t is equal to 0. Okay, that means starting of the time t is equal to 0. Identifies a cruiser moving 50 kilometer due west and moving due north with a constant speed of 20 kilometer per hour. Okay, the unit vector blah blah blah, and the origin is taken as o. Origin is taken as o to be the initial position of the destroyer. So this is where the destroyer is. So this is where the destroyer is. Okay, so let me write, this is the destroyer over here. And what was destroyer doing? It was moving due west at a constant speed of 10 km per hour. So we know north, south, east, west. So this particular destroyer is moving west. So I will give an arrow mark west at 10 km per hour. So this is 10. Instead of writing 10 km per hour, if we are writing the velocity, it's going to be minus. Okay, it's going left, right? Because this is 0 and this is a negative. This is 0, negative axis. So minus 10 I kilometer per hour is my velocity over here. Okay, this is destroyer moving this way. So the destroyer is over here, and the destroyer is identifying a cruiser 50 kilometer due west. So 50 kilometer, let's say each unit is 1 kilometer. So here it got what is it, a cruiser. So let's say the cruiser is over here. So this is where the cruiser is. Okay, cruiser is moving, it is at 50 I. How much is it? Minus 50 I. So minus 50 I is the initial position. What is the initial position of destroyer, by the way? Because since it's in origin, it's in 0 I and 0 j. Okay, and what is the initial position vector of the cruiser? Minus 50 I, and they said it is in due west, so that's the reason I took left hand side. This is origin, and it is moving north, so it's moving northwards. It's moving northwards at how much? 20 kilometer per hour. So we can write, since it's going up in the j direction, because this is j direction and this is I direction, these are I, so it will be 20 j kilometer per hour is its velocity. Okay, okay. So now let's say write down the velocity of each vessel. We already got the velocity of each vessel. So velocity of the destroyer, so let me just write it Vd. Velocity of the destroyer is minus 10 I kilometer per hour. I already explained why. And velocity of the cruiser is how much was it? It's going north, so 20 j kilometer per hour. 20 j kilometer per hour. Now find the position vector of each vessel at time t hours. Basically they are saying us to find this equation. I hope you guys know that if you know the velocity and initial position vector of an object, you can find where it is going to be after certain time t. So this is the equation is final position vector is equal to initial position vector plus velocity into time. So in this case, your r is, what is your r over here? Initial position, oh, sorry, yeah, now we have to find for each vessel over here. So let's talk about final position vector of the destroyer. So rd, what was the initial position vector of the destroyer? That is going to be 0. What was the velocity it was moving with? Minus 10 I. Okay, and time t. So that means overall final position vector depends on minus 10 it. Okay, now let's talk about the cruiser. So this is your cruiser RC. Cruiser's initial position vector, we know it's minus 50 I. So minus 50 I plus velocity, it is moving with 20 j and t. So this is the final position vector of both of them. So A part is done, B part is also done. Now let's go to C part. In C part, they said show that the distance d kilometer, the distance between both of them at between the vessel at time t hours. Like for example, after some time t, For example, let's say let me use different color. Let's say the destroyer has reached here, and let's say the what's his name, yeah, the cruiser reached over here. Okay, so there is a displacement between them, right? There is a displacement between them. How do you find the displacement? Remember, displacement between two position is found by minusing, by differentiating between both of their vectors. This two. Okay, this is cruiser's vector after certain time t. This is the destroyer's vector after certain time t. So, so now let's say what is their displacement after certain time t. So what I would do Rd minus Rc. Okay, so displacement equals to, let me, yeah, I change the color. Displacement equals to Rd minus Rc. Oh no, you know what? Since there is a minus, let me do Rc minus Rd. That would be better because that would be easier. The minus sign makes everything anyway complicated. So Rd, Rc minus Rd. Okay. So if I minus both of them, it's minus 50I plus 20JT minus of minus 10IT. So if you do it, it's going to be minus 50I plus 20JT plus 10IT. So if you want, you can make all the I vector common. So if you do that, it's going to be minus 50 plus 10T I plus 20 Tj. Now this is a displacement. What are they looking for? They're looking for the distance. Since they are looking for the distance, we have to find the magnitude of our displacement. Okay, so magnitude of the displacement is distance. So that's what we are going to find. D is equal to root of vector I square, that is going to be minus 50 plus 10t whole square. This is t. 10t whole square. Let me rub that. Doesn't look good. Okay. So whole square plus 20t. Now if you come down, if you scroll down, you have to solve this root. If you transfer the root on the other side, it becomes square. So d square, we got whatever was there in the question. Let me open this bracket. If I open this bracket, it's going to be minus 50 square minus 2 into 50 into 10t plus 10t square. Oh, I forgot to do q square over here. Plus 20t square. Okay, so let's open the bracket now. If we open the bracket, I have lots of space over here. Let me use that. D square is equal to minus 50 square. Let's do that in the calculator. Minus 50 square. Minus 50 square is minus 2500. Okay, minus 50 into 10 into 2, 1000 minus 1000 t. Okay, plus 100 t square. 20 square, how much is 20 square? It's around 400 t square. 400 t square. So if I add this to, it's going to be 500 t square minus 1000 t minus 2500. That's what our t square is all about. Okay, so and you can see, okay, I have some sign issues. Okay, this is minus. Since it's a square, it's going to be a positive. So this is going to be positive, and I was able to prove, and we proved that it is this equation, C part. Okay, so done, hence shown. Let me make a box here. Okay, so now they said the radar on the cruiser detects, so the cruiser can only detect anything that is within 40 kilometer. Mostly this is civilian ship, this is a military ship, so they will have a bigger range radar, and this one will have very small range, so they can only detect anyone within 40 kilometer, which is enough for any small cruisers to avoid collision. So by finding the minimum, and whenever they talk on minimum, the differentiation which we learned in our P2 or C2, okay, it will come handy. Now determine whether destroyed will be detected by the radar. Okay then. Uh, okay, so now let's do differentiation over here. If we do differentiation of this, because they said to find the minimum, it's going to be 1000 t square. Okay, It is dy by dx. I don't know how to say it. Let's do d square by t. Okay, differentiation, like dy by dx. Okay, 1000 t square minus 1000. Okay, so now if we find it equals to 0, because they told us to find minimum. Whenever it's minimum, dy by dx equals to 0. So 1000 t square minus 1000 is equal to 1000. Okay, so cancel, 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 cancel. T is going to be 1. That means at 1 hour. Okay, so now substitute T, determine whether the destroyer will be detected by the cruiser. So your T is equal to 1. Now if I substitute that T in the main equation at the first hour, 1 hour, if I substitute T in main equation over here, here and here, I will get my minimum distance. So d square is equal to 500 into 1 square minus 1000 into 1 plus 2500. So that's going to be 500 minus 1000, okay, plus 2500. I just wanted to know whether it's in meter or in kilometer. It's given in kilometer. Where it is it? Okay, is it 1? Now 2500. Let's see how much we are getting. 500 minus 1000 plus 2500. So I'm getting 2000 around d square. So d is equal to root of 2000. Okay, so root of the answer, that's coming around 44. So yeah, the cruiser can detect the destroyer because this is the minimum kilometer it can see. So the final conclusion is, since 44.7 kilometer, the cruiser can detect 44.7 kilometer. Oh, actually, I made a mistake, I think. Yeah, the cruiser can detect only 40 kilometer. So since the destroyer is 44.7 kilometer, so it is greater than the minimum range the cruiser has. So not detected. Okay, I hope you guys understood this question. Okay.